In this example, we have given a product of three functions. We have a theta, sine theta, and then cosine theta, right? And we have a product between that. So this is the product of these three different functions. And our goal is to find the derivative of this function with respect to theta. How do we find the derivative of these? The question could be, how do you find the derivative of the product of the function? We know that if we have the two function f and g, and if there is a new function which is the product of f and g, then the derivative of these can be figured out by, let's say, this formula, which is write down the one of the function as it is, multiply by the derivative of the g plus, and then you can just do the derivative of the f, and then they write down the second function as it is, and then do the product like that. And this is a kind of product rule, right? So but if you look into this product rule carefully, what is happening here is, if we have a product of two functions, then we have one function, we will have two terms, right? On one term we write down the one of the function as it is, and then multiply that by the derivative of the another function, and do the same thing on the another term, but just leave. For example, let's say we here write down f as it is, multiply by g prime, and then plus find the derivative of f, and then multiply that with the g. So each time just do the derivative of the ones, and then leave the other function as it is, and then find the product in that way. So if this is the case, we can generalize this idea, and then actually the generalization will be true. If we have a product of three function, let's say, then we can generalize this idea as leave one of the function as it is, right? And then find the derivative of the one of the function, and then multiply the derivative of that derivative by the product of another two function, and repeat this process again. So here on the first term we find the derivative of the f, let's find the derivative of the g on the second, and then leave the function f and h as it is, and then we have not figured out the derivative of the h, so find the derivative of the h, and then leave the function f and g as it is, and then find the product of these three terms in this way, right? So this is what the kind of generalization of the product rule. So if that is the case, why don't we just use this type of procedure over here to find the derivative of the product of three function? So what is the procedure here then? Just find the derivative on this case, then derivative of the theta with respect to theta, right? And then multiply this derivative with the product of the remaining function, plus, now we can repeat this process again. So last time we differentiate theta, so let's leave the theta as it is, and just find the derivative of the sine theta on the second term, and then also write down the cosine theta. So we'll do the product of theta, the derivative of the sine theta, and cosine theta. And on the last term, what we do here is leave the theta, the product of the theta times sine theta as it is, and multiply by the derivative of the cosine theta, right? So that's what we need to do it. And you can clearly see each time we are just finding the derivative of one of the factor, and then we are writing down the product of the remaining terms, and then just use this formula over here. So I believe we have properly used the generalization of the product rule. So if that is the case, let's find the derivative now. So derivative of the theta with respect to theta will be just 1, right? So we have then 1 times sine theta times cosine theta is in the first term, plus theta times what is the derivative of the sine theta with respect to theta, cosine theta, right? So we can write that down, and then plus we have theta times the product of theta times sine theta, and we can then now just find the derivative of the cosine theta with respect to theta, which is negative sine theta, right? Okay, let's write that down. And this is the derivative of the product of these given three and the function. But let's try to see if we can simplify a little bit further. Okay, so on the first term we have 1 times sine theta times cosine theta is sine theta times cosine theta, and then on the second term we can multiply to cosine theta, the cosine theta with cosine theta, then we'll have cosine square theta and then times theta, right? And then on the last term, then on the similar way, we will have theta times negative theta times sine square theta, right? Because sine theta times negative sine theta will be negative sine square theta, and then times theta will be negative theta times sine square theta. So this could be one of the alternative to the form of the derivative that we needed to figure out. Or if you want to actually, if you know some of the other trig identity, here you can do one of the another alternative answer you can write down between these two term over here. I can see that theta is a common factor. We can take that out. When we do that, the remainder will be cosine square theta minus sine square theta. And we know that the cosine square theta minus sine square theta, if you know the double angle identity, that can be changed into cosine 2 theta. So if that is the case, we can rewrite the derivative of the given function as sine theta times cosine theta plus cosine 2 theta, right? So one of these could be one of the alternative derivative form, but still if you know the half angle identity, actually we can also do something else over here. So this is sine theta times cosine theta, and we know that the sine 2 theta is the double angle formula. Sine 2 theta is equal to what is that one, 2 times sine theta times cosine theta. So if that is the case, I mean, if you solve for sine theta times cosine theta, this expression over here can be written as sine 2 theta over 2, or 1/2 sine 2 theta, right? If you solve for sine theta plus cosine theta plus theta times cosine 2 theta. So this could be another alternative. Whatever, you know, the alternative you decide, you write it down. All of them produce the same rate of change for the given function, right? In this case, determined by yourself what type of alternative form you need it, but one of these is the derivative of this given function. And then the key thing here is how to apply the product rule for the product of more than two functions. And then one of these could be your answer.